So good evening, guys. Yesterday we discussed about body fluid, and today we will continue with fluid distribution. Okay. So fluid distribution. Okay. For fluid distribution, we have a diagram or a Darrow net diagram. Okay. In which in this diagram we have on horizontal axis we have volume, and on vertical axis we have osmolarity. Okay. One side we have ECF and another side we have ICF. Okay. This is called Darrow-Yannet diagram. And after that we have three rules. What are the three rules? Number one rule is osmolarity of ICF is equal to ECF. Okay. And rule number two is ICF osmolarity inversely proportional ICF volume. Okay. And rule number three we have ICF volume inversely proportional ECF osmolarity or ECF osmolarity. So it means if there is any change in ECF volume, it will not change ICF volume. Okay. Whenever ECF osmolarity will change, only in that case ICF volume will change, and after that ICF volume will change, then ICF osmolarity will change. Okay. Then we have three type of solution. I think everybody knows we have three type of solution. Number one, isotonic solution means solute equal to water, or we can say solute equal to solvent. Okay. And number second we have hypotonic solution. According to this, solute is very less than water. A solution in which water is more and solute is less. Okay. Number third, hypertonic solution. According to this, solutes are more than water. A solution in which we have solutes more than water. Okay. Then we will apply this concept. We will apply all these rules and isotonic, hypotonic or hypertonic solution concept in Darrow-Yannet for diagram. Okay. So this is our Darrow-Yannet diagram. This side we have ECF, this side we have ICF. This is osmolarity, and there is volume on horizontal axis. On vertical axis we have osmolarity. Okay. So first case, if we will add isotonic solution. ECF means everybody knows, I think. ECF means plasma and interstitial fluid. Okay. So if we are adding isotonic solution, what are the example of isotonic solution? Isotonic solution means 0.9 9% NaCl or normal saline. Okay, so in isotonic solution, you know now solute is equal to solvent. Okay, so if we will add isotonic solution, if we will add isotonic solution to the body, it will directly go to the ECF. I already told you yesterday that if we want to anything inside in our body or we want to remove from our body solution, we are talking about solution, okay, or salt or solutes, okay, we have to deal with the direct plasma or ECF. Okay, so when we will add isotonic solution in ECF, in that case what will happen with ECF volume? What happened with ECF volume? ECF volume will increase or not? It will increase. So graph will shift like this. ECF volume will increase like this. Okay, and what about osmolarity? What about osmolarity? Will ECF osmolarity will change or not? No, ECF osmolarity will not change, will not increase or will not decrease, because we are adding isotonic solution. Means we are adding whatever amount of solute, same amount of water we are injecting in body. Okay, so in that case only volume will increase, only volume will increase. Okay, ECF osmolarity will not change. ECF osmolarity will not change. And we have rule number 3. If ECF osmolarity will not change, then ICF volume will change? No. If ICF volume will not change, then ICF osmolarity will change? No. Okay, so in that case we will get final this graph like this. We can draw here same ECF and ICF, and here this side increased only volume. Okay, so ICF will not change. ICF osmolarity and volume will not change. Okay, second case we have. In second case, if we are removing or loss of isotonic from body, we are removing solute or whatever solute we are removing. Okay, so we have to remove from, everybody know, from only ECF. We'll remove from the ECF. Okay, so in that case same we have again our formula diagram. This is ECF, this is ICF. Okay, and we are removing isotonic solution. So ECF volume will decrease because we are removing. ECF volume will decrease. ECF volume will decrease, and graph become like this. Become like this. Okay, this is ICF, ECF. Okay, ECF volume will decrease. What happened with ECF osmolarity? It will change or not? No, because we are removing what? Isotonic. We are removing water also, at the same amount we are removing solute also. Okay, so in that case ECF osmolarity will not change. ECF osmolarity not change. And if ECF osmolarity will not change, ICF volume not change, and ICF volume will not change. So ICF osmolarity will not change. Okay, so if we are adding isotonic solution, in that case only ICF volume will increase. Rest ECF osmolarity, ICF osmolarity or ICF volume remain same. And if we are removing or loss of isotonic from body, in that case only ECF volume will decrease. ECF osmolarity will remain same, and ICF volume and osmolarity remain same. Okay, then we have third case. In third case, we have adding hypotonic solution. Adding hypotonic solution. Before that, we have example of loss of isotonic solution. Examples are, for example, diarrhea, vomiting, or hemorrhage. Diarrhea, vomiting, or hemorrhage. Okay. So adding, now we have adding hypotonic solution. Hypotonic solution means adding means we are adding more water or less solutes. We are adding like this. Okay. So again we have diagram. This diagram we have ECF and this side we have ICF. Here we have volume. Here we have osmolarity. We have volume. Okay. So now we are adding water and solute also we are adding. Okay, but we are adding mainly water and we are mainly adding water. Okay, so suppose we are adding water here, means volume ECF volume will increase, definitely will increase ECF volume. And what about ECF osmolarity? ECF osmolarity, we are adding more water and less solutes. It means ECF osmolarity will decrease. You can consider osmolarity means concentration. Okay, so osmolarity will decrease. So graph will be like this. Volume will increase like this. Okay, volume graph will be here, and osmolarity will decrease. So final graph we will get like this. Now, in that case, osmolarity, ECF osmolarity decrease. If ECF osmolarity decrease, then ICF volume will increase. Rule number 3, ICF volume will increase. So what happened with ICF? ICF volume will shift like this. Volume will increase. Now this is the volume. And rule number 2, if ICF volume will increase, then ICF osmolarity, what happened with the ICF osmolarity? ICF osmolarity will decrease. ICF osmolarity will decrease. So same here, osmolarity will decrease until both osmolarity ECF and ICF become same. Rule number 1, ICF equal to ECF. Okay, so in that case, if we are adding hypotonic solution, okay, in that case ECF volume will increase, ECF osmolarity will decrease, and ICF volume will increase and ICF osmolarity will decrease. Okay, now we have fourth case. This is third. And what is the example? What is the example of this hypotonic solution? The example of this is SIAD, as syndrome of inappropriate ADH, in which we have ADH secretion increase, and ADH is responsible for reabsorption of H2O from renal. Okay, so we are adding hypotonic solution. Okay, and now fourth case, we have fourth case. Okay, in fourth case we are removing hypotonic solution, or we can loss of hypotonic solution. Example of this, diabetes insipidus, in which ADH decrease, and if ADH will decrease, no one will absorb water. Absorption of H2O will not take place, and loss of water means we are losing water. Mainly we are losing water. Okay, So in that case again we have a diagram. What is this? This is ECF. This side we have ICF. This side we have volume, again volume and osmolarity. Okay. Now we will apply this. We are removing hypotonic solvent. We are removing water. So what will happen with ECF volume? What will happen with ECF? What will happen with ECF volume? We are removing hypotonic solvent. We are removing water. Means ECF volume will decrease. ECF volume will decrease, and we are removing less solute. So ECF osmolarity, we are removing more water and less solute. So ECF osmolarity will increase. ECF osmolarity will increase. And rule number 3, if ECF osmolarity will increase, in that case ICF volume will decrease. If ICF volume will decrease, then ICF osmolarity will increase until ICF equal to ECF osmolarity. Okay. So how we will do like this? ECF volume will decrease. ECF volume decrease like this, and osmolarity will increase. So we will get diagram like this. Final diagram will be like this. Volume will decrease and osmolarity will increase. Then we have ICF volume will decrease. So ICF volume will decrease this way. This one is the ICF volume, and ICF osmolarity will increase. ICF osmolarity will increase until ICF or ECF osmolarity become similar. Okay. This is the example of removing hypotonic solution. Okay. So now we have fifth case. Now we have fifth case. We are adding, okay, hypertonic solution. For example, 3% NaCl. 3% NaCl is a hypertonic solution example, or we can say seawater. Okay. In this case, we have same. Again, we have a diagram. Okay. ECF and ICF. Okay. Here we have volume, osmolarity, and volume. Now we will apply. We are adding more solute. We are adding more solute or less water. Still we are adding water. So volume will increase. We are adding very less water. Volume will increase, little bit increase. But we are adding lots of solute. So concentration will, or osmolarity will increase. So the graph will be, or the diagram will be like this. So ECF volume definitely increase, because if we are adding any solution, definitely volume will increase. And ECF osmolarity, what about ECF osmolarity? Osmolarity also increase. Okay. If ECF osmolarity will increase, then ICF volume will decrease. If ICF volume will decrease, then ICF osmolarity will increase until both osmolarity become same. So now we have another diagram. ICF volume will decrease. ICF volume will decrease. Here we have can say ICF volume will decrease and ICF osmolarity will increase. It will increase until ECF or ICF volume or osmolarity become same. This is the example case of adding hypertonic solution. So now we have sixth case. In sixth case, last, we are removing or can say loss of hypertonic hypertonic solution. Loss of hypertonic solution. It means loss of more solutes or more sodium ion or ions. Okay. Same example: decrease ACTH, adrenal insufficiency. Adrenal insufficiency. Because if there is no ACTH level will decrease, adrenal will not release aldosterone. Aldosterone. If there is no aldosterone, then no reabsorption of sodium ion in collecting duct. Okay. If there is no aldosterone, it means there is no reabsorption of sodium ion, means loss of sodium. So how we will apply in diagram? Suppose we have this diagram again, ECF and we have ICF. Here we have osmolarity and here we have volume. We have volume on horizontal. Okay. So now we will apply. First, we are removing hypertonic solution. Okay. Still we are removing hypertonic solution, means we are removing sodium ion. Still we are removing some water also. So ECF volume will decrease. ECF volume will decrease. Okay. ECF volume will decrease. And ECF, what happened with ECF? Osmolarity, or can say concentration. If we are removing lots of sodium ion, little bit water, so we will remove little bit water, means graph will be like this, and we are removing lots of sodium, so osmolarity will decrease. Osmolarity will decrease. Concentration will decrease. Concentration will decrease. If ECF osmolarity decrease, in that case ICF volume will increase. ICF volume will increase. And if ICF volume will increase, then ICF osmolarity, simple, ICF osmolarity will decrease until ECF or ICF osmolarity become same. So now we will apply this in ICF. ICF volume will increase. ICF volume will increase this way. This is the final graph of ICF volume. Okay. And ICF osmolarity will decrease. So ICF osmolarity will decrease. This is the final graph of ICF osmolarity, and this is the final graph of ECF osmolarity. Okay. So guys, this is fluid distribution. Okay. And today we will finish a small topic. Tomorrow we will discuss about homeostasis and acid-base balance. Okay. Buffer. This we will study tomorrow, and I will upload a video in Insta also and YouTube also. Okay. Thank you. Good night.